our last measure that we're going to talk about is the mode. So the mode is just the most frequently occurring value, the thing that we would see more often than the other values in a data set. So what we generally want to do as we're actually finding this thing is put things in order first, because then we'll see repeated values, right? This is going to be the thing that's repeated most often, actually, in that data set. And one thing that we need to address right away is that there may be no mode, there may be one of them, or there may be multiple modes. So let me go through some examples so you see what I'm talking about there. The previous things I talked about with the mean and the median, there's just the one number, and it always exists, at least, right? So let's go through this first example of the mode. As I see 11379, well, 379 only appear once, but this number 1 appears twice here, more than any of the other values, so it's the mode. I have one mode, and it's the number 1. All right, in the second example, 113379, 1 and 3 both appear twice. Nothing appears more than twice, so those are my modes. There's 2 of them, and my modes are 1 and 3 then, in that case. Now let's look at this situation where I don't have anything repeat. Well, I don't want to say literally every value in the data set is a mode, like that becomes pretty much useless information. Instead, I want to say that there's no mode. And that's telling me that nothing appears more than once, nothing appears more frequently than any other value. That's what the mode is supposed to be telling us, is what number or what value or values appear more often than the other numbers. If nothing's appearing more often than anything else, right? I've got this 13479, nothing is a mode, right? So when I've got the situation where nothing appears more than once, I want to say that there's no mode. And I put this caution here. Do not write the mode is 0, right? Because I get this every once in a while, right? Meaning there's like no mode there. Well, no, if I say the mode, right, if we're like on an exam and I've got these numbers written here and I'm like mean equals, median equals, mode equals, and you're just supposed to fill in what the number is. In this case, you do not want to put 0. That means there is a mode, 0, and that 0 appears more than any other value. Well, I don't even have the number 0 in this data set. It's definitely not the mode, right? So I don't want to write that. Just write none, NA, no mode, right? Any of that's reasonable, right, in an exam situation. If you're doing online homework, it will tell you what to write if there's no mode. But just make sure you're not writing this 0. That's not what that would mean, okay? So just be aware of that, that I could have no mode, I could have one mode, or I could have multiple modes, right? It's all possible, which makes this kind of an awkward to deal with measure, but it does have a purpose, right? So I'm going to go through the purposes of these 3 measures that I just went through. So the mode is the only measure I could use with categorical data, right? We've talked about that we've got numerical data and we've got categorical data. If I'm looking at, right, what language you speak at home, right? English, Spanish, Chinese, Russian, like whatever, right? I can't put those in numerical order and pick the middle value, right? The median doesn't even make sense here. I can't add those numbers up. There's no arithmetic to do with languages that you speak, right? So the only thing I can do is use the mode. So that's its most useful situation, most useful application is when I'm using categorical data. But in either case, whether I'm doing numerical or categorical data, it will always have that same interpretation that it's the most frequently seen value. Okay, but it's, as I said, main purpose, I would argue, is for categorical data. Because the other 2 can't even be used there, and it's at least telling us what the most frequent value is. So the median is easy to interpret, right? About half my data is less and about half is more. And it gives a true center value, right, where we can actually understand what that center means, right? It's literally the center of my data set. even when I have outliers, right? Because those are, by definition, if I have like everything in numeric order, my outlier is going to be either way over here or way over here. It will never be in the middle, right? Otherwise, it's not an outlier. An outlier has to be far away from the other values. That either means it's way lower or way higher than the other values. So it's not going to be that middle value. And as I'm just arranging things in order, that median's not really going to be affected by those outliers. So when I have issues with outliers, and as we talked about in the section about distribution shapes, when I have significant skew in one direction or another, which leads to outliers, I'm often going to want to pick the median because it's not going to be affected so strongly by that. This mean is harder to interpret. It's got some great properties in more advanced statistics courses that I'm just not going to get to in an intro, intro to statistics section in a math class. But it can give us this expected value per unit. Let me give you an example for the city of Casper, just to kind of get this idea across. So suppose we're told that the mean home price in Casper is $300,000. Okay. Well, there's going to be a bunch of homes that are a little bit cheaper than that, and there's going to be some homes that are way more than that. These home prices are pretty much always right skewed because, right, like there's a minimum value that people would ever take for their house. But as far as a maximum value, right, you could have multi-million-dollar mansions, and well, there is a multi-million-dollar mansion here in town, right? So we'll get this kind of right skew. We're going to have outliers. And so that mean may not be the best representative of a typical home price in Casper, but here's what it does. The city of Casper, when they're figuring out, right, because our schools are funded by property taxes, they can just count up how many houses there are and say, okay, let's multiply that by our mean of 300,000, and that's going to tell us what our total taxable properties taxes are going to be. And if we're just taxed at, 1% or 2% or whatever it is, right, they can just find 1 or 2% of that, because what it's doing is telling us a per unit, per house in this case, value. And as, right, if we build 500 new homes over a year, they can actually project what their increased tax revenue is going to be, because we know per unit how much we're expecting to see, regardless of the variability, right? So even though some are going to be way cheaper and some are going to be way more expensive than that mean of 300,000, they'll still be able to understand a per unit calculation that we can do here. And just as one last example, just because this thing gets discounted so often of like, well, the mean is the center of mass, what do you even really use it for? Again, advanced statistics definitely has some great uses, but I also have seen this in ecology as they're looking at the total amount of fish pollutants, in other words, their poop and their pee, right, that they make in a lake, right? That's literally the biomass of the fish. Well, you've got little tiny baby fish, and you've got these massive, like 40-year-old fish all in the same lake. Well, if we just find the mean weight and we know roughly what the population is in the lake, we can figure out what the total biomass is what it's called is of the fish in that lake. And we can figure out how much food they're ingesting in total. And we can also figure out how much waste products they're producing in total, because we know what that mean is, and that can get tied to the population because we know per fish how much of that intake and output we're actually getting. So it can be a very useful thing. It's just in some situations it because of its weakness to outliers, because of its sensitivity that it moves in one direction or another, it can sometimes be a poor representation of the middle. So as long as we know the pluses and the minuses of these measures, we can make the right choice and interpret things better as we're being given that data.